Right, so here we are with the promised boxed Realistic TRC1001. So we did one about 5 days ago, which was, it got a broken aerial, but I'll discuss how to sort that out with a scrap AM set probably. So, for those who want to know, box 26, radio is 5 of 8 from this box, and it's the Realistic 1001. So I'd love this to perform as well as the other one did. But there's always a possibility it doesn't perform as well as the other one did. The other's a Mark II, the later one. This could be the earlier one. I love these pictures. Now, what construction crew is going to be using a CB with a 1.5 metre aerial? Come on. And what fireman looking person is going to be using a radio with a 1.5 metre telescopic? But the hunter could be, I suppose, fishing and hunting. Yeah. So they do recommend you can buy the 211172 microphone, which we had with the other one. We'll be using our standard replacement microphone to do the test with this. And when we tested this mic, my standard mic, the internal mic, of course the internal mic works the best, but the convenience from an external mic means that you can show it on the seat of your car and use it legally without being nobbled by people thinking you're using a phone. So we'll carefully open this box from 1981. These were £119.99. The first set I got. In fact, I did actually have a Harvard 020 because the Realistic 1001 I ordered just wasn't available for a couple of weeks. So I thought, well, I'll get on for day one, which I did. And it smells of chips. Fried food. And that very first day, I was working on an organ at near Osberton Hall. Interesting organ, 1890s electric action. So you think about that, electric action pipe organ. It was a Hope Jones. Scofton is the village, private estate village. And I was still on my apprenticeship then, and I asked the boss if he'd be kind enough to stop off at New Ollerton at the post office so I could buy a licence. So I parted with my £10. I came out, pulled up the aerial on my Harvard 020 200 milliwatt handheld, which we know is a good day with the wind behind and will work for 3/4 of a mile. And that particular version was channel 14 and 19. I put it on 19 and went 1.9 for a copy. And you know what? I got one. And it was another young chap's first. He got a binary on Route 66 and he was about quarter of a mile away. And of course there's nobody on. It was day one. Fantastic. Anyway, my Realistic 1001 appeared a couple of weeks later. This has lost its dust caps. And they go brittle at this age, so it's how it is. I don't know what you can do. So we're going to look at this aerial. We're going to pull it up very carefully, as you should always do. A tip from somebody was a light, some WD-40 on a cloth from time to time can help with these. We always put them down from the bottom, not like on these American TV shows where they snap them down from the top and then you end up with the literally snapped off. So we'll put this through its paces. Remember, it's a 12.5 volt radio. Look at that battery compartment. Yeah, that's pretty pristine. I'll still run over it with the fiberglass brush just in case. I'll better just jot down the serial number. 463029. So we'll still be looking for dry joints even if it doesn't play up, because every one of these is suffering from those interboard dry joints these days. We'll start off on the internal mic. I'll find my adapter. You remember, we've got, by the time we've got an adapter tree on here, we've got a lot of losses in receive, not so much with transmit, and we'll be looking at ridiculous amounts of microvolts on the signal generator, but it isn't true. So this is a Motorola adapter. I will take that cap off very carefully. It's about the only one still in existence. I bet this has never been off in its life. Oh, this is not easy. I'm going to have to put something underneath it, but we don't want to mar the set either. I have to try and lever this. That's not going to do it. What about the great big rusty screwdriver? Now it's broken the tip off that. You know, this is what's going to happen. I have got to get that cap off. Let's try it from the other side. I've never had this problem. Are these cutters big enough? Yeah. That has really taken some getting off. And it's as hard as they come. So as a precaution, we're just going to run around that again with the fiberglass brush. Put it in high power for now. So we haven't got that. We're going to need to take this speaker one out, and that's still attached by its strap. And it's very stiff. I've got to get that to one side enough to get the plug in. I don't want to break that off. It's as brittle as anything. And that's how they've gone. Right, I mean they're 40 years old, aren't they? So we'll plug that into there. We've got a power lead Mr. Chippy made up for an emergency set, which also fits this. So once again, it's 12.5 volts maximum. If you want to run it from the car with the engine running, we would put 3 diodes in series inside your cigarette lighter plug, so you're dropping the voltage a bit, and that's quite adequate, 1 amp diodes. And that's exactly how the factory original adapter worked. So 12 volts, power on. Come on, 19. And display goes out unless you press either the little button in the middle, or you turn the channel switch to save battery power. And if I tell you it's drawing 48 milliamps at the moment on standby, if I put the display on, it's 116 milliamps, so it's a really good, worthwhile thing, that. So we'll switch picture in picture on. We'll start with transmit. I'll put the test set on the 3 watt scale because it's a 3.5 watt set, and they usually do about 2.7. And this one's doing 2.2. The last one, I remember, we managed to get it up to 3.1, and that's fine. It worked very well. Yep. So let's go to channel something. 2.2. 0.15. Back to channel 20. Low power. 110 milliwatts. It's not adjustable, that, but it should come up as we bring up the other powers. They're gonna try and be 10 decibels or whatever it is. Anyway, and then let's just look at the transmit current. It's 699 milliamps. Deviation is probably about 1.4. Let's have a look. Wallow. It's 1.8. Never did like the AGC on these. It over deviates for your first half syllable. We're not doing the VCO unless we have to do the VCO. Let's look at the frequency. Let's put the appropriate camera on. 2779125, 2779097. So it's not actually off frequency. We'll try and bring that up. It's well within the spec. So what we'll do is we'll set the signal generator to match the radio, which is not quite on frequency, so it's a fair test. I'm doing this at 8:30 in the morning because we've got organ tuning booked this afternoon. Coming up near Eastern, it's usually the once a year tunings that organs tend to get. 79097. That looks fair enough. So we will try and plug in the test equipment. I'm scared stiff this is going to snap off. I'll hold the range boost side panels to earth it. So for 12 dB we've got 3 microvolts. For 10 dB got 2.5 microvolts. Let's see if we can get 20. We can. And it is 7.8. So take that with a pinch of salt, it isn't deaf. Squelch isn't adjustable, but just for the record, tight is 9 microvolts, and the threshold, oh, always turn the wrong one. No, it's still the wrong one. .7 microvolts. Again, this is all linked because you got losses in the phono stroke Motorola connector. So it has an RF meter, which is on the top. I'll change glasses because I need an electron microscope to see it. So in receive, it's the battery meter, which is what we're on now. It's not an S meter, and it isn't on the LCD version of the 1005 either. It's still a battery meter on receive. On transmit, it's relative RF, and it's gone right across, which it will do. So that's okay. That's not there. We'll turn it to low power and you'll see the difference. Back to higher power. There you go. So switches, pots, sockets, not available, not applicable. Everything else is fine. So really we just need to see if we can bring the transmit up to where it should be. I'll turn it off, we'll pop these screws out. So you've got the one in the back. There's none in the battery compartment on this version. And then we'll be revealing whether it's a Mark 1 or a Mark 2. Really the only difference is you've got a power adjusting preset potentiometer in the Mark 2, and you haven't. I think there were one or two which were over the power they should have been, so they had to do something about it. So we're going to unsolder the speaker. It's the later Mark II version. Isn't that nice? So we've got the same potential dry joints, and I'm going to go through those because if it's not playing up today, it will be playing up tomorrow. So I think there's 9 of them. I can see that one at the edges. This one's been done at some time. I've got 3 here. Just move that resistor to one side with the soldering iron. Right, hopefully that'll be good for another 40 years. We'll have to take the pesky VCO can off. We'll do the frequency in a bit. So I'm going to, as usual, have to use the service manual. Don't see enough of them, even if we only saw one a bit back. T8 L8 L9. Perhaps just point this out now with something. Start. Next, 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 next. Good. That's the one you don't touch. It's done with the spectrum analyzer, second harmonic. Now we have a different tool for this in the expensive green set. And usually you're going to have to get rid of the snowflakey stuff, or the paint, or whatever they've used. You think, well, they can't have moved because they've been sealed, but of course the component valves have moved, haven't they, because of age. I think that one's come away the best. Because all that happens if you don't do this is you'll end up breaking the core. Right, let's see if we can move it. Yeah. Right, let's go over to the main meter. So there we have a bit more. Okay, no change there. Not got enough of this stuff off. This is the one I thought I'd done well with. Yep, got it. Okay, so we're not getting any change. We're at 2.3. And what did we start off at? 2.2. So now we'll adjust the power preset. I'll probably scrape some stuff off that as well. That's moving now. Change scales. We've gone both for 3 watts. It's 3.1. I'm just going to go through these again. .2. So channel 1 so that's well balanced. Good. I'm pleased about that. We've got it up, and we've got it a little tiny bit more than the other one. But we have got losses in this adapter, so don't worry about it. Now, low power. 160 milliwatts. Could be 170 milliwatts. And the power consumption now... Oh, I did that on channel 40. Silly person. 150 milliwatts. And the power consumption on high power is now 940 milliamps. So it can eat your batteries quicker. So transmit deviation is that one. I think it's the only preset in the radio apart from the power one. See if that's anywhere near. Wallow. I'm on the wrong scale. Silly fool. Wallow. It's too high. Wallow. Still too high. Spot on. Now we need to check that with an external mic. Wallow. Just drop that down a fraction more. Wallow. I'll use the tone generator. Wallow. Yeah, I think we're there. I'll put that on one side because we're going to need it in a bit. So we've got an average of 2.2 and it's peaking at 2.5. We're not going to do the VCO. These aren't susceptible to problems with that. I've still got to go in this pesky can though. So I've turned the power off. I need to force this open with a screwdriver. Now all this knackered foam rubber is being disturbed. be honest, that shifted it enough to get to the trimmer. As long as you make sure you don't short out things up there. Yeah. There we go. Switch it off again and try and coax this back in. There we are. Right, I'm aware that the PTT switch is going to need some spraying. Come back to that. It's not always going in, not always making. So that's transmit covered. Let's see if we can get anything more on the receive. So I'll put the oscilloscope on, we'll have a look at the detector. When we've looked on the circuit diagram, or whatever, where it is. Transformer 4. 5, 4. You've actually gained a bit there, which is nice. I think you've just got these three. I'll just check. One, 2, 3, and 5. 1, 2, 3, and 5. So over to the cyanide meter. Let's have a 4 dB on there so we can see the difference. Well, there could be a difference, but we'll see. 12 dB is now I'm not holding on to the set, am I? I was gonna say it's much worse. Hold on to the set. It's 3. That's exactly what it was before. Ten. 2.7. I don't think it is worse. It's just the way it is. You know, I can just redo that. Holding it this time, it's 3. You know, so this is the difficulty. 20. Got 9. I think the fact the lid's off is making a difference here. Let me just I could say 8.5. There is no difference in reality. Squelch threshold is going to be just the same because there's no adjustment. So all we've done is to bring the detector slightly up, and it was so minute. I mean, that receiver was absolutely spot on. So what we've done, we've got the set from 2.2 watts to 3.2 watts, and we've got the deviation up where it should be. We've got the set back on frequency. So there you are. I've gone through for dry joints. Just check that screw's tight. Yep. So I'll have to come back to this and bring the service hole with the spout. I think Mr. Chippy's had his one back off here. Right, so that's just sprayed the PTT switch with the service hole. Get this speaker soldered back in. This speaker is about the size of what you get in a mobile these days. So we'll get those started underneath, and then I'll put the back screw in. It's good practice not to tighten anything fully until all the screws are in. On anything, that is. I'm going to do the sensitivity test one more time with the lid on. Put picture-in-picture back on, show the attenuator. There we go. So making sure the signal generator is on frequency. Let's go through these once again. Tell you what, no, we'll put the sine meter on. So we'll start with we'll start with 12, but I'm going to have to hold it, aren't I? So there's 12, and it is 0.27. So there's, on this scale, lower scale, 0.5, 0.27. So it's different again, you see. Let's go for the 10. That's 10, all right. 0.2, 0. Where are we? No, it's 2.7, wasn't it? 2.7 there. So you've got to take all this with a pinch of salt because of the way the adapters are. 2.7, we're at 2.5 and a bit. So we can say 2.55, and then the other one 20. It's, every time I get another reading on this, it's different. It's 9. So I've had 7.8, 8.5 and 9. You know, this is what you're up against. Let's try it again. You know, 8.5 that time, you know, so this is how it is. So just check squelch works. Get a reading off that. That is 20 microvolts. Now that's improved. And the sensitive end, set threshold on the radio. I've got to hold on to it, haven't I? It's 1.8. So it's just basically the same as before. So that's fine. Double check. It is. Still good. Right, we'll just go on the air with it. I'll use our extension standard mic. Take that out. We'll put that cap. No, we won't put the cap back in because we're going to run it on extension speaker. I don't want to be handling that cap more than I need to. So turn the signal generator off. Plug the Antron 99 roof aerial in. Let's see if we can hear any bad buddies out there. One Nano, Roger. Right, well we've got two sensible conversations going on, and that's great. So we'll do an on-the-air test later on, and what a lovely set. Thanks for watching.